This time, we have to evaluate the integral of z squared dz from 0 to 1 plus I. So we have here again the integral of your z squared dz from 0 to 1 plus I. This is a version of definite integral for our given complex number. But of course, we're going to apply here the same rules for integration. So this is actually equivalent to, we know that our form here is, of course, would follow u to the n du, which would give us u to the n plus 1 over n plus 1. Our n here is 2, so we are expecting here a result of z cubed, or of course that's 2 plus 1 over 2 plus 1, or again that's just simply z cubed over 3 to be evaluated from 0 to 1 plus I. Okay, so as simple as that. And of course, you are to substitute your boundaries for your definite integral to get the result. So this is actually equivalent to the upper, you have here 1 plus I cubed over 3 minus 0 cubed over 3. Now we can take away the second term, as we know that already to be 0. So we just simply need to provide here the form for our numerator. Now it's a cube of a binomial. You can of course apply the special products. So you have here 1 cubed plus 3. Then you have here 1 squared times your second term plus 3 times 1 times the square of your second term. And you have here plus the cube of your second term. They're all over 3. Okay, so once you do that, simply look at those possibilities that will allow you to really simplify specific I squareds. Let's simply continue here. That's 1 plus 3i. We know that I squared, specifically for this one here, I squared is negative 1. So this would be equivalent to minus 3, because that's 3 times 1 times negative 1. And for your I cube, it's actually I squared times I. Again, I squared is negative 1. That would give us negative I. So this means we have here minus I over 3. Hopefully you're following. Again, I cube is I squared times I squared being negative 1. In short, I cube is negative I. Combining the terms on our numerator, 1 minus 3 is negative 2. 3i minus I is positive 2i over 3. And since none of the terms can be simplified, you can even break this into two terms just to see the real part, which is minus 2/3, and the imaginary part, which is 2/3 I, containing the imaginary unit I. This is the result for this integral of z squared dz from 0 to 1 plus I. Thank you very much for watching.